Hi, and welcome back to fractions. This is the second video, which is multiplying and dividing fractions. And I do have here the mathematical notations and the mathematical theorems for fraction multiplication and fraction division. But really, it is very straightforward. Whenever we are multiplying two fractions together, all you are doing is multiplying the top with the top and the bottom with the bottom. So I just really like to draw in just that. I like to say top with top, bottom with bottom. That's what I'm going to do. So top with top, bottom with bottom. Okay, so in my two examples that I have here, the first one is a fraction. Two fractions multiplied together. The only thing we do need to keep track of is that the first fraction, 11 over 12, is negative. So I always like to assign the negative to either the top or the bottom. Typically, I would assign it to the numerator. So I'm just going to rewrite it with the negative in the numerator, and I'm multiplying it by the second fraction, which is 5/7. And we just literally multiply across, top with top, bottom with bottom. So let's go ahead and do that. Negative 11 times 5 is negative 55. And 12 times 7 is 84. And I really can't simplify that at all. So I am just going to leave that as my final answer, which is negative 55 over 84. Okay, so that's our first example. Now the second example is a fraction, and then I'm multiplying it by just negative 20 over x, which I can rewrite again as a fraction. And again, I'm going to assign both negatives to the numerator. So I'm going to rewrite this as negative 12 over 5 times negative 20x over 1. Okay, so you can always rewrite something as a fraction by putting it over 1. Now, here you can, again, multiply top with top, bottom with bottom. But I noticed something interesting. I actually noticed that 5 goes into 20 4 times. And so what I'm going to do is I'm actually going to go ahead and do that so that it'll save me a little bit of time at the end when I don't need to simplify. So 5 goes into 20 4 times, so this becomes negative 4. And the 5 becomes 1 because 5 divided by 5 is 1. Negative 20 divided by 5 is negative 4. And then I go ahead and multiply top with top, bottom with bottom. My denominator becomes easy because it's 1 times 1, which is just 1. And then I have negative 12 multiplied by 4, which is 48. Negative and a negative becomes a positive, so it is a positive 48. And let's not forget the fact I have a variable, so my final answer here is 48x. And notice I do not need to simplify anything because I already simplified right at the beginning, which is great. So those are my two examples for fractions with multiplying fractions. Now, I do have a few examples with fraction division. And what we need to remember with fraction division is that that first fraction is always going to stay the same. And I can rewrite the division as a multiplication problem by flipping the second fraction. So notice if I flip the position of C and D, I can rewrite it as a multiplication problem. So let's practice doing that. So I can rewrite negative 2/3 divided by n over 5 as, and I'm going to keep the first fraction the same, I'm just going to assign the negative to the numerator. So 2/3, I change the division to multiplication, and I flip that second fraction. So I now have 5 over n. And then I just do, again, top with top, bottom with bottom. So I have negative 10 over 3n. I cannot simplify, and so that would be my final answer. Pretty straightforward. Let's practice with the second one. Again, we're going to change this division problem to a multiplication. I am going to rewrite the first fraction exactly as is. I'm just going to assign the negative to the numerator, so that's 7/8. We change the division to multiplication, and then that second fraction, we are going to flip it. Okay, so we're going to write down the reciprocal, and again, I'm just going to keep that negative with the numerator, my new numerator, which is 27 over 14. Now, I'm going to go ahead and do some simplifying because I noticed that 7 goes into 14 twice. So 7 divided by 7 is 1, so it becomes a negative 1. And 14 divided by 7 is 2. Okay. And that's pretty much all I can do. So now I'm going to go ahead and do top with top, bottom with bottom. Keep in mind I'm multiplying a negative 1 times a negative 27, which becomes a positive 27. And then I'm doing 8 times 2, which is 16. I really can't do anything else with that. So that is my final answer. Okay, now I will go ahead and show you the next two examples, and they are written in a slightly different way. Keep in mind that this fraction bar is really saying divide the top fraction by the bottom fraction. Okay, so that's what we are going to do. I'm essentially going to rewrite this as 3/4, which is my numerator fraction, and I'm going to just write divided by, because that's what the fraction bar means. That's what the quotient means. Divided by the second fraction, which is 5/8. And again, I can rewrite that as a multiplication problem. So times my reciprocal of 5/8, which is 8/5. And I can go ahead and simplify. 4 goes into 8 twice, and 4 goes into 4 once. And then we do top with top and bottom with bottom. So 3 times 2, 6. 1 times 5, 5. And that's my simplified fraction. Okay, so let's practice with the second one. Again, my numerator, my first fraction is x over 2. And I'm going to rewrite that as a division problem. And my denominator is xy over 6. And I can rewrite that as a multiplication problem. You keep the first fraction the same times the reciprocal of the second. So it's 6 over xy. Now, I am going to change colors for this one just because I don't want to get us confused with the x's. So x goes into x once, x goes into x once, so the x's cancel. And 2 goes into 6 3 times, and 2 goes into 2 once. So now we do top with top, bottom with bottom. So this becomes 3 over 1 times y, which is just plain old y. And that is our final answer. Now we are not going to go ahead and do these again because we want to make sure that we talk about order of operations before we actually go into those a little bit more complex simplifications. So I'll see you next time. Thank you for watching.